So our first active filter we're going to look at is actually just a generalized first order or single pole filter. So this is going to be a general circuit, and we're going to come back in later videos and we're going to sort of expand on this. So you'll notice that this configuration with our op amp looks very familiar to what we have seen before. And so this is actually the same as our inverting configuration that we saw in our op amps unit. The only difference is instead of resistors, I now have these impedances, Zi and Zf. So I have an input impedance and I have a feedback impedance. And so it turns out that our transfer function is going to be the same as we saw before. The only difference is now we're going to have impedances instead of resistances. So our V out over Vi, which before we were calling our gain, now we're going to call that our transfer function, is going to be negative Zf divided by Zi. And so what we're going to see is, as I've already mentioned, this is a generalized filter. So this is going to be a generalized either high pass or low pass. And so whether it's high pass or low pass is going to depend on where we put our capacitor. So because this is an active filter and because I have these impedances, either Z1 or Zf will have a capacitor. And so remember, we don't have any inductors in these active filters, so all of our sort of imaginary component of our impedance is coming from our capacitor. And where we put that capacitor, we'll see in following videos, is going to determine whether we have a high pass or a low pass. So if we put it in the feedback network up here, we're going to get one type of response, and if we put it in the input network, we're going to have a different type of response. So one thing to note too is, again, we're sort of starting with the simplest case, a first order filter. Of course, we could make this higher order by adding more poles. So for instance, we could have a second order or a two pole filter. And what that's going to do, as we have talked about with our passive filter, is that's going to make our actual sort of cutoff a little sharper and better approximate that ideal filter.